Hey guys, welcome to DSA-n-Design. Today we will learn about linked list and we will be covering the below topics. First, basics of linked list, and then how to implement a linked list, and then finally how to print a linked list, right? So before even we start anything about linked list, we want to understand what is linked list, right? And why do we need linked list, right? So linked list, and what is the basically why do we need so we already have array, right? We already have array. What is the advantage that linked list is actually providing over array, right? So quick understanding about this is important, I feel, right? So look, link array is basically kind of stores the value, similar value, which is of a in a continuous memory, right? In your disk, we need a continuous set of memory to store some value. For example, let's say I have five different numbers that I need to store, right? So this is how I will store. So 10, 20, 30, 40, and 50, right? So let's say these are the five different value that I want to store. And then my address should be, let's say, address for this is 100. This should be 101, 102, 103, and 104. Something like this we need to actually store. So it should be actually in my memory. There should be a continuous space available for me to actually store if I want to store something in array, right? Now, when coming to linked list will provide you something where you don't need a continuous set of memory to store the values, right? So what we can do here is basically we can store any location where it is available, each of this value. For example, let's say I have this value 10 and I have 20 here, I have 40 here, right? I can store wherever in my memory is required, right? 50 here, and let's say 30 here, isn't it? The most important thing is what I will do is I will actually provide a pointer to this particular value at the node that we will learn what we talk about. But this is how actually we can actually point it so that everything is actually stored in a kind of in a logical fashion, right? So this is what the linked list provide you. So linked list will help you if you don't need a huge amount of space, continuous space. Rather, if you have space in multiple locations in your disk, then you can actually go with the linked list, and that is the best thing that linked list provides, right? Now, let's try to understand what is linked list basically, and what is basically how do we implement the linked list, right? So let's go and dive deeper a little bit about it. So linked list basically what it is, basically it's a collection of node, right? Collection of node basically. All right, collection of nodes. Now the question is, what is node, right? What is node basically? So node is nothing but actually it's a class. All right, class in object oriented or class in Java. So we'll actually cover from the point of view Java, right? So it's basically a class, right? And then how do we actually create these nodes, and how do we implement the overall linked list? That let's try to understand here. All right, but before that, let's try to understand what exactly it node is, right? So as I said, let's say I need to store 10 or 5 different, for example, there is a roll number, right, of student roll number that I need to store, for example, 10, 20, 30, 40, and 50. One second. So this is, for example, 50, right? That I need to store. This is how actually we can, allow for array, right? In array, that is how actually we store, right? But in linked list, the similar thing can be done, but we don't need a continuous memory. That's what we learn actually, right? But now we will learn about node. What exactly is node? As we said, node is basically a class, right? And what exactly node will store? Node will store two things, right? For example, let me see how we can store in the linked list, right? So this is, let's say I'm going to create five different nodes, right? Node is nothing but it's basically a value, okay? And it will also store something called next. which is nothing but another node. So for example, let's say I have node n1, n2, n3, n4, and 5. For example, this location is, let's say, 1k. Location for this particular node is 2k in memory, right? 3k, 6k, and 8k, something like that, right? We are giving actually some location for all of these nodes. So all these nodes can be created anywhere, right? For example, for value 10, I created one, and next will always be null until we actually connect, right? So this is also value, for this also value. Let's put a value, right, for each of them. So this is going to be 50, this is 40, this is 30, and this is 20, right? Now what we will do is, this is something next. Next means how do I connect n1 to n2, right? How do I connect? Because this next is nothing but its address basically, right? So for this particular node n1, what is the address? It's 1k, right? 1k is the address in memory. And now I want to actually connect this node to this node, because I want basically to say that, okay, this is my this is basically linked to this. How do I link it? I actually can link it like this pictorially. But then in order to link it, what I will do is I will actually store next. Next should be stored with n2. So what is the address of n2? It's 2k. So it says that n1 is basically connected to n2, and then I am saying that what is next of n1 is actually n2, which is basically this, right? Similar way, what we can do is we can also connect n2 here, right? So here I say next equal to n3. N3 is what? Basically 3k, right? So this is how it is connected. Similarly, you can connect this, and you can connect this as well. So the last one, this is basically next will be null. Why it will be null? It will be null because there is no other node pointing to this, right? So this node is n5 is not pointing to anything. It is actually pointing to null. There is no further node, right? But then this is how actually we can do. So basically we will store two value in that particular class or this particular node. One is value and another one is the location, or we'll say the address of the next node, just to connect it, right? So this is what about little bit about understanding. Let's try to see how actually we can implement in Java, right, on the code wise. So let's go here and try to understand basically, right? And so let's see that I will create a class called node. All right, it will have two basically attributes. One is val, and then another one, as I said, node. Okay, it will be node. Second, it will be actually node type, right? It will be node, and it will be called as next. This is the name of the variable, right? Now I'll create a constructor, right? Constructor will actually say int val, all right? And now inside this, I will say this dot val equal to val. Fine. This is what actually I need to say for a node, right? Now what we will do, um, we will actually go to my main, right? And in my main, what we will do is basically we will create multiple nodes, right? So for example, I will actually say node n1 equal to new node 10, right? This is what constructor is taking, right? The value 10. So I want to create a node with value 10, right? And what it will do actually, you see that? So the moment I run this particular line, what will happen? Actually, it will create a node that we have shown just before, right? So it will create node n1, and this is, let's say, 1k location, right? And value will be 10. What will be the value of next, guys? Next value of next will be null here. Why? Because we are not actually initiating any value here. This is by default value of this particular node. Node is what, guys? Node is nothing but it's a class type, right? Class type. That's why it is actually initiating with null value, right? Now, second line, what we will do is here. Let's see if we actually say node n2. The moment I create a new node n2 with value 20, let's say, right? I'm just saying 20. This point of time, another node will be created in memory, right? and until this, right? So let's say n2 and this is at 2k, for example, right? Any location. Now value will be 20 here, and then what will be the next, guys? Next will be again null. Why it's null? Because we have actually initiated this. We just created it right now. Okay. Now in the second step, till now these two nodes are created in memory at the different location. They are not in continuous location, right? Now the beauty, look at the beauty. How actually I want actually all of this node to be making a linked list, right? Linked list is what? The collection of node, right? So I'll try to make a linked list. So which will be one node will be linked to other node, right? What we will do now here is we will try to connect node n1 with node n2. So I will write something like this here. Okay. So I'll say do n1 on right. I'll assign next value to n1 dot next equal to n2. What it will do actually? You see that n1 is this one node, and this node is n2. n1 dot next, when I say, means this particular value null is there, no? It will be actually assigned with 2k, because what is the value of n2? The address of n2 basically it's 2k, right? That's how this n1 will be actually connected to this. Now I have this linked list n1 and n2. There are two nodes, and kind of n1's value is 10 and n2 values is 20, and n1's next, what is the next node for n1? How it is linked is basically 2k, which means n2. It is connected to n2. Now for n2, what is the next? It's still null because there is no further node, right? Correct? So this is how actually this linked list will work, right? Now what I can also do is I can actually make this particular node as a head node. So what I can say, one more line, head node head equal to n1. All right. So this will be like pointing to a head node, right? Head node is nothing but in generally in linked list, right? We give a head node which will actually the starting point of any linked list, right? So generally in linked list question we will be getting a head node, and then you have to traverse throughout the linked list or do whatever operation you want to do, right? So this is about the basics of linked list. What we will do quickly now is basically we will try to actually uh, implement this linked list in Java, right? Let's go to ID and then try to create class, and we'll do the creation part of linked list. All right, so let's go. I'll create a new Java. I will say node, give the name as node. Anything you can give, guys, but generally we are actually giving node because kind of this is the general convention, isn't it? That's why. So what I said, I'll create int val. I'll also create node next, and then constructor. I will say node and int val. All right, and now I will see. Uh, all right, I'll say this dot val equal to val. All right, this is what we are done here. Now we will say uh, public static void main, public static void main. All right, inside this I will actually create the nodes, right? I'll create first node, node n1 equal to new node, right? New node 10. All right, now node n2. I'll create okay, this is new, right? So this is new. I'll say new node 20. Now node n3. Let's create three nodes for now. Okay, you can create as many as you want, but let's create three nodes actually, 30. All right, guys. So we are done actually. So now in memory, as I showed, there will be three nodes created. Now what I have to do, first thing what I have to do, I will actually create the first node as a head node. Okay. So what we'll do, let's say node head. I'll assign n1. Now head node, actually this is separate, right? Now head node is pointing to n1, right? This is the first node. Now what I will do, I will link n1 to n2 and n2 to n3 just to make a linked list, right? So I'll say n1 dot next equal to n2. Now I'll say n2 dot next equal to n3. Now what is happening is it actually n1 is linked to n2 and n2 is linked to n3. Now 10 is linked to 20, 20 is linked to 30, but head is still pointing to this node, right? This is what it is. I think this is okay. Hope you understand this, right? So we are not doing anything. We just created a simple class with one constructor, and actually we are using this constructor. We are just creating different nodes, and after that we are linking the nodes, right? Similar way here what we have done actually, if you look at it, correct? So we link to. Now what is the, let's try to understand here a little bit. What we have done so far is we have created three nodes, right? One, two, three. This is n1, this is n2, n3, right? Not n second. Okay, this is actually, this is n1, right? N1, n2, n3. Location may be 100 and 100, 120. It's not contiguous, right? And 500, let's say. Something like this location is there. Now I will say value equal to 10, and next, the moment we created it, right, it was actually null, no? So let's put value first here, 20, value equal to 30, right? And what is next here? Next is also null till now. Here also next is null. The moment we created, right, and we after that we linked, right? N1 dot next we said no. So this is how it was linked, right? Here it says 120. This is the address of this particular node, right? And now for address of n2, I mean next node for n2 will be 500, and for this it will be null only because this is not pointing anywhere else, right? Now what we will do is we actually created a linked list. Now my linked list is ready. What I want to do is I want to actually traverse this linked list and I want to print the linked list, right? What I will do is basically, now look very carefully, right? I want to actually we'll go and we'll code it as well, but for now just try to understand. Print the linked list. What we will do now is we will actually, we already know this is basically okay, so we all also have actually make it head, right? We already know the head node, so head node actually pointing to this particular node. Now I have to, using this head node, I will actually travel to all of these nodes and I will print the value of each of this node, right? So how we will do is basically we will let's try to see that. Okay, what we will do, we will actually don't want to interfere with anything with the head, but I'll create a new node and I will store in this head node the address of head node in a temp variable, right? So that I can play around with the temp, right? Now this is what the first line I will do to print it, right? And then next what we will do, I will say while. In while I will not put right now any value, okay? Will not put, we will put the condition later, but for try to understand what exactly we want to do, right? So now the temp is actually pointing to head node, which is actually n1, right? N1 are the head node, so we are actually start of the node. So first of all I will do actually, I will do print it actually, okay? So I'll say temp dot val, right? It will print me 10 actually, right? And then after that, after printing this, I will actually next to the next move to the next pointer, right? Next node basically. So how to move to the next, actually using this temp equal to temp dot next. So next time I actually this is making sure that temp is now storing the next node, correct? Next node is basically here, no? Next node is 120. I am actually at n2, right? I am at n2. So how I am moving, see how beautifully temp equal to temp dot next. And what is temp dot next, guys? See, temp dot next is 120, which means actually I moved. My temp is now storing 120 here, right? I move to 120 now, right? Now the same thing, it will actually come here again, print 120. So this time actually when it comes, it will actually print 20, and the next time it comes 30, right? But there should be a condition when I need to stop, right? So while condition will tell me stop. So when exactly ideally I should stop? Can you think and tell me? The moment I come to N3, shall I stop at N3? I mean, to stop at N3, what should I say? So look, when I come to N3, right? And after that, n3 dot next, if I say n3 dot next, it will be actually null, right? So shall I stop at n3? Yes, exactly. When the moment I reach to n3, after printing n3, right? After printing n3, I will actually move to n3 dot next, right? And that's where I need to stop. So I'll say I will actually say temp when up to what point I have to continue moving is until my temp is not null. Temp is not null. When is my temp is not null? Actually here. I'll move here, right? This is a node, correct? Which is actually outside this, right? So no node actually. Just assume that. Next, when I say temp dot next, okay? Temp equal to temp dot next here, correct? No? Temp equal to temp dot next. The moment I actually come after this, right, after n3, the temp will be pointing to what? Temp will be pointing to null. Look here, this is pointing to null. So I printed 30. After that, my temp become null because temp dot next equal to, there is nothing actually, right? So temp dot next equal to null here, right? So there is no other node further. So my condition should be actually I need to continue until my temp become null, means I have no further node after that, right? So this is how actually you can print, right? So let's quickly try to code it and try to see how actually we can print this particular linked list. All right. Now, what I can do is, so let's do this one, this part, right? So I'll say it while we already know, right? We already know what is head now. Head is pointing to n1. Now what we'll do is we will actually, as I said, we will maybe let's create a function. I think that will be better, right? Let's create a function here, here, right? I'll say print linked list, and what should be static. Okay, I'll say public static. I just want to print, isn't it? I don't want to return anything. Void, sorry, void print linked list, and I'll give here node actually, right? So what is that node? Head node actually I'll give. Now what we will do is we will try to kind of say, I just said I'll store this head node in a temp variable. So I'll say head. Now I'll say while we said, right, temp is not null. Until temp is having some value, some address, I will continue to print. The moment it points to null, I mean there is no other point node, I will stop it, right? So I'll say here is system. I'll just print it, right? System dot out dot print, correct? I will say just here that I want to print, what I want to print? I want to print temp. Temp is what? It's basically pointing to head, no? So I'll just say temp dot val. We have two attributes for this particular node, no? One is val and other one is next, right? And then after this, what I will do, I'll actually move to the next node. So I'll say temp dot next. All right, after printing this, right? Now what it will do is it will actually print and it will move to the next pointer until this pointer become null, right? I mean there is no further pointer, right? So this is the way how we have to do. Now let's try to call this basically and try to see this is not void, this is void. Okay, now let's go here, guys. Okay, I'll just call this simply function and then I'll pass the head here. Okay, we already have head here, no? The head is pointing. Now let's try to run this. This should print me 10, 20 and 30, right? Oops, I think this is going somewhere else. Let me go to current file, I think. Okay, now let's see. This is printing 10, 20, 30. Let me give some, maybe I'll print in the next line. Okay, all of them, all this value I'll print in the next. All right, you see 10, 20, 30. 10, 20, 30, it actually printed. So right, so this is how actually you can print a linked list, you can create a linked list, and you can print a linked list. Yeah, so that's all for this video, guys, and let's continue to learn. We'll try to cover entire aspects about linked list, right, in this series, and yeah. and many others to complete, right? And yeah, so for now, I think we are done. And thanks for watching. And if you are new to this channel, I request you all to actually subscribe and share with your friends. All right. And this is going to be a unique kind of channel where you learn each and every aspects about design, DSA and design. Yeah. Thank you. Thanks for watching. Bye. Take care.